Today we shall discuss the examples based on the yesterday's theory. Okay, here there is first example. Okay, say this is your example number 2.1. Calculate the angle of 1 degree, 1 minute, 1 second in the radian. Okay, now if you want to find degree in radian, then just you have to multiply by pi upon 180. Okay, and that pi upon 180 is simplified for you. Okay, it has been simplified. If it is 3.14 divided by 180, then this much you will get. Now you just have to multiply by this. Okay, if you want to convert that 1 degree, okay, into radian. Okay, so if you want to convert 1 degree in radian, then you just have to multiply 1 degree by pi upon 180, and pi upon 180 you will get this much. Okay, now the second thing, okay, you want to convert the B part. Okay, 1 minute. Okay, so first of all 1 minute is converted into degree, so you just have to multiply or rather divide 1 minute divided by 60. So this answer will be in degree, and then you multiply this by 1.745 into 10 raised to minus 2 into 10 raised to minus 2, and you will get the answer which is given here. Okay, so that will be in radian. Okay, now 1 second. Okay, so 1 second, if you want to convert first of all in minute and then in degree, yesterday we discussed. Okay, so 1 second is converted in first of all minute. Now if you want to convert that 1 second in minute, then what you should do? 1 second, okay, 1 second divided by 60, so that will give you the answer in minute, and this is again divided by 60, so that answer you will get in degree. So this yesterday we discussed is 1 upon 3600, and you multiply this by again say pi upon 180, that is pi is 3.14 divided by 3600 multiply by 180. So just you have to divide 3.14, okay, by 3600, whatever answer comes that you have to divide by 180. You can use calculator and you can get the answer, that is 4.85, okay, into 10 raised to minus 6. Okay, so this is a very easy calculation. By using calculator you can do this whole thing. Okay, now there is a second example. A man wishes to estimate the distance of a nearby tower from him. He stands at a point A in front of tower C. Okay, now tower is given the name C and he is in front of the tower C. Okay, so here say this is the point C where the tower is, and the person is standing in front of the tower. Say this is the initial point of this person. Okay, now just you read that data. Okay, and spots a very distant object O. Say this is a distant object. Okay, and he spots this object. He is looking at this object from his position at A. Okay, now what does he do? Then he walks perpendicular to AC, so he goes in this direction. Okay, how much does he go? He goes by 100 meter. Okay, again from this point he spots this distant object. He is looking at this object. Okay, the direction DO. Okay, say this is the position of that person after walking 100 meter. Okay, since O is very distant, the direction this BO is practically the same as AO. So the direction of AO and direction of BO, they are as such same. But he finds the line of sight of C. Okay, he finds the line of sight of C. C, if he views from this point, okay, then that point C can be seen by that person at certain angle theta, and that theta is given how much he has to look towards, or how much he has to bend, or how much he has to change his face if he wants to see the tower. Okay, this is given to you, but he finds the line of sight of C shifted from the original line of sight by an angle theta, that is 40 degree. Okay, that is given, or theta is nothing but a parallax. Estimate the distance. Now you can easily find. See, these are as such two parallel lines. Okay, I am showing it by a different color. Okay, so you can understand it easily. These are two parallel lines and this becomes a transversal. So alternate angles are always equal. So if this is say 40 degree, then this has to be 40 degree, and you can find now AC easily, isn't it? You can take 10 40 10 40. Okay, 10 40 is opposite. Opposite is how much? AB. AB is 100 upon adjacent. Okay, opposite upon adjacent. Adjacent is AC. AC we want to calculate. So you can now easily take AC as a subject of formula. Okay, AC is equal to 100 upon 1040. Now how to find the value of 1040? You find out this from the natural tangent table, which is given in the log table. You just purchase a log table and find the table of natural tangent, and in that the first column which is there, okay, that will give you the angles in degrees. So that angle you just have to locate 40, and in front of 40 the value is written. Okay, and if you divide this 100 by that value which is obtained from the table, okay, that is round about 0.8391. 0.8391. Okay, you will get the answer of AC round about 119 meter. Okay, so this is again an easy one, or just you have to use the mathematics. Okay, now you can go through the next one. 2.3. Moon is observed from two diametrically opposite points A and B on Earth. The angle theta subtended at the moon by two diametrically directions of observation is 1 degree 54 minute. Now how to read this, that also you should know. Okay, you should know this is spoken as 1 degree 54 minute. given the diameter of the earth is, or earth's diameter is given to diametrically opposite points the persons were located. Okay, so you have to just find out what. Okay, you just have to find the distance of the moon from the earth. Now theta is given. Okay, theta is given. Theta is 1 degree 54 minutes. So first of all, everything is converted into one particular degree. Okay, or rather 1 unit. Now 1 degree is 60 minute. Try to understand. 1 degree is 60 minute plus 54 minute, which is given. Okay, so total it becomes 114 minute. Okay, so it is written 114 minute. Now 1 minute is how much? 60 seconds. So just you convert this 114 minute into second by multiplying 60, and then you get the whole data as a second. And if you want to convert that second into radian, we know we have to multiply by 4.85 into 10 raised to minus 6. So everything will be converted into radian. Okay, this can be done with the help of calculator easily. Okay, now we have small b, or we can say the value of diameter, the distance of diametrically opposite points. Yesterday we discussed it this way. Okay, you must know that how to calculate it. Okay, say for example, this is the earth and these are the two diametrically opposite points. Okay, and the moon is somewhere here, and if it is seen like this, okay, then these are the two diametrically opposite point on the earth, which is denoted by b. This angle is given to us, say theta, and d we want to calculate. So this arc that is b is equal to, arc is equal to radius, that is d, multiply by theta. Theta we found in radian. Okay, so d, that is capital D, can be b upon theta, and the value of b is given to us. Okay, it is 1.276 into 10 raised to 7. 1.276 into 10 raised to 7 meter. Okay, divided by the answer of the angle in radian, that is 3.32. Okay, 3.32 into 10 to the power minus 2. 10 to the power minus 2. Simplify this and you will get the answer, that is round about 3.84 into 10 raised to 8 meter. Okay, so we will get this 3.84 into 10 raised to 8 meter. Okay, now we have another example. The sun's angular diameter is measured to be 1920 second. Now it is second. Try to understand. This value which is given to us is in second. Okay. The distance d of the sun from the earth is also known to us. What is the diameter of the sun? Okay. So angular diameter is known to us. We want to find out the diameter of the sun. Now yesterday we discussed about this also. Okay, say for example, you have the sun in front of the earth like this, we show. Okay, say this is the sun and you are here on the earth somewhere. Okay, and you are viewing the two edges of the sun from this point, and this angular diameter is known to you, or we can say this angle is known to you, and that angle is 1920 seconds. We want to find out this value, that is its diameter. Okay, say this diameter is denoted here by say D. Diameter D is to be calculated. Okay, and the distance of the sun from the earth is known to you, that is capital D. Now this becomes your arc. Okay, this becomes the arc. Okay, this is the arc. So arc is equal to radius. Radius is capital D. Okay, radius multiply by the angle theta. So theta is here shown by alpha. Now that 1920 has to be converted into radian by multiplying 4.85 into 10 raised to minus 6. So you just have to multiply these two quantities, D and alpha. D is known to you. What is the distance? Distance is 1.49 into 10 raised to 11. So 1.49 into 10 raised to 11 multiply by 1920, and that is in seconds. So you just have to multiply it by 4.85 into 10 to the power minus 6. Okay, so simplify this by using calculator and you will get the answer of this calculation. Okay, so this calculation gives you the answer 1.39 into 10 to the power 9 meter. Okay, now there is an estimation of very small distance or size of molecule. The whole process is narrated here. The distance of very small to very large distance we are measuring in physics. Very small distances are having the unit angstrom. Okay, and 1 angstrom is 10 raised to minus 10 meter. Okay, so you will study wherever we need this. Right now you just remember this much only. What is 1 angstrom? And if you want to measure the height, or we can say the very small thickness, okay, then it is monomolecular layer method. That method is used to measure the very small layer. Okay, so the idea is to first form monomolecular layer of oleic acid. Now that method of measuring very thin distance or very small distance, okay, size of the order of 10 to the power minus 9 can be measured with the help of this method. You just remember the name of method, monomolecular layer method. Okay, now there is the range of length. Okay, this ranges of length you should remember. Okay, and the conversions you should know. Okay, this you should remember. This is important for different small questions. Okay, 1 Fermi is 1 F is 10 to the power minus 15 meter. Okay, or sometimes it is written as 1 femtometer 10 to the power minus 15 meter. 1 angstrom is 10 to the power minus 10 meter. Okay, then very large distance, that is astronomical unit, is the unit of those large distance. And what is 1 astronomical unit? Average distance of the sun from the earth. Say this is your earth and here this is the sun. This average distance between the sun and the earth is known as the astronomical unit, and its value is 1.496 into 10 to the power 11 meter. Okay, so 1 AU is 1.496 into 10 to the power plus 11 meter. Now 1 light year. Okay, 1 light year means distance traveled by light in a year. What is the speed of light? As you know, 3 into 10 raised to 8 meter per second. In 1 second it travels 3 lakh kilometer, or 3 into 10 raised to 8 meter. Okay, so at this speed what how much distance does it travel in 1 year. Okay, and the value is 9.46 into 10 to the power 15 meter. That is the distance that light travels with the velocity of 3 into 10 raised to 8 meter per second. Okay, in 1 year. Then there is another unit, 1 parsec. Okay, 1 parsec is 3.08 into 10 to the power 16 meter. Okay, parsec is the distance at which average radius of the Earth's orbit subtend an angle of 1 arc second. 1 arc second means what is the angle? 1 second angle. Sorry, 1 second angle. 1 arc second means 1 second angle. The distance should subtend. Now, what is the distance? The distance that you have to understand is the radius of the Earth's orbit. Now, what is the distance of radius of orbit? Okay, say for example, this is the sun, okay, and this is the Earth, okay, and Earth is moving around the sun. So, this is the radius of the Earth's orbit. Now, radius of the Earth's orbit is nothing but the average distance between the sun and the Earth. And what is the distance between sun and the Earth? The distance between sun and the Earth is nothing but 1 astronomical unit, and it is 1.496 into 10 raised to 11 meter. So, if you take 1.496 into 10 raised to 11 meter distance, okay, how much distance you are taking? You are taking 1.496. So the distance that you are taking is 1.496 meter. So the distance I am taking, I am showing it here. This is a distance 1.496 into 10 raised to 11 meter. Now this distance, when it is taken at this large distance, at a very large distance, where does it make an angle of 1 arc second? Try to understand. This distance of 1 astronomical unit subtends an angle of 1 second. Then, okay, at a point, okay, this distance, what is that distance? 1 astronomical unit. Okay, the distance between the sun and the earth is nothing but 1 astronomical unit, and that is 1.496 into 10 raised to 11. Okay, now that much distance in space somewhere will subtend an angle of 1 second. So certain point somewhere here, this distance is subtending an angle of say 1 second. Okay, so this is the point where 1 second angle is subtended. So this particular distance, okay, is nothing but 1 parsec. 1 parsec. Okay, so this distance 1 parsec is 3.08 into 10 raised to 16. So parsec is the distance at which the average radius of Earth's orbit subtends an angle of 1 arc second. Okay, so here at this distance, at 1 parsec distance, okay, the Earth's orbit subtends an angle of 1 second. So this 1 parsec, કેટલું distance મળે? Okay, you can find this. This is 1 second. Okay, now this is your arc. This can be considered as arc. And arc is equal to radius multiplied by theta. Now radius we want to find. Okay, so if you give the name, say AB is your arc. Okay, arc is equal to radius we want to find. Okay, this distance we want to find. So arc is equal to radius multiplied by theta. Now r we want to find, so r is equal to, you can convert this, okay, arc AB, okay, arc AB is equal to radius multiplied by theta. So r can be made as a subject of formula. Okay, so it becomes arc upon theta. Theta has to be in radian. So 1 second angle has to be converted in radian. Okay, and you simplify. So 1.496 into 10 raised to 11 divided by the angle theta. Theta is how much? 1 second. 1 second has to be multiplied by 4.85 into 10 raised to minus 6 to convert it into radian, and if you simplify, then you will get 3.08 into 10 raised to 16 meters. So 1 parsec, you just remember. Okay, it can be asked somewhere in MCQ or in short question that what is 1 parsec. 1 parsec is 3.08 into 10 raised to 16 meter. Okay, go through this, read from the textbook. You got the textbook today. Okay, and revise this 2-3 times. Okay, thank you.